Today's lesson is a continuation of our theme of linear functions, and we have what's a specific type of linear relationship or linear function called a direct variation. So let's investigate what we're talking about with a direct variation. We have this scenario where Jill and Lisa are babysitters, and Jill charges 15 an hour, while Lisa charges $12.50 an hour plus $5 for gas. So let's take a look at each person's situation and write an equation. Jill would simply be y equals 15x. X is the hours, and y is the money they're going to earn. And it says make a table of values from 0 to 5. Very straightforward. So Jill would make $15 an hour, and we would see it as such. Okay? Now we take a look at what Lisa does. Lisa's equation is y equals 1250x plus $5. And when we make that table of values, it's a little tight here, sorry. $17.50, 30, 42.50, it's a little tight, sorry, 55, and 67.50. Okay? Now we want to graph both of these relationships, and I'm going to label hours, dollars, no choice there. The hours we're just going to count from 0 to 5. And you always look at your table of values to give you an idea. We have to go up to $75, so I'm going to count by fives. So 5, 20, 30, 40, 50, 60, 70, and 80. So I'm going to use the same colors that I've used on the side to show each person's graph. So Jill is going to start at 0, 0. At 1, she's going to be at 15. 2, she's going to be at 30. 3, 45. 4, 60. And 5, 75. That's such. And then Lisa, at 0 hours, she's going to be at 5. 1, she's going to be at 17.50. Somewhere around there. 2, she's going to be at 30. 3, she's going to be at 42. 50. 4, she's going to be at 55. And 5, she's going to be at 67.50. Now, not great as straight lines, but now, a couple of things that you can answer from this. One is you'll see that at 2 hours they both make the same amount of money, but then what you'll see is the hours increase. Jill is going to make more money because the green is above the red. Now, what is different about each of the equation, and is each person's earnings a function only of the hours worked? Okay. Well, if you notice, Lisa has a y-intercept of $5. All right. Jill's is 0. Okay. Because Jill doesn't get paid anything until she starts babysitting, while Lisa theoretically gets that $5. And what would the scenario be? All right, so let's say Lisa drives, shows up, and the family wasn't able to get a hold of her and say, oh, we don't need you tonight to babysit, but here's the $5 for the gas. Okay? Jill's earnings is solely, sorry, spelling there, is solely a function of hours. Lisa's is not. And the reason I've put these two here is to show you or contrast for you the two, because a direct variation in math is a relationship that can be represented by the function y equals kx, where k is not 0. Okay? If you notice, obviously, again, in math, we use different variables to tell us different things. We're using k here instead of the traditional m for slope, and I'll tell you why and what the k stands for in a moment. But what you should distinctly notice is that what's missing from this direct variation is a y-intercept, so that therefore the y-intercept is really 0. So you should note the y-intercept is 0, which means the graph goes through the origin. Okay. Now, what is k? K is what's called the constant of variation. K in the equation above is the constant of variation. Okay? It is also known as the constant, and you'll see why in a couple examples, also known as the constant of proportionality. So, again, all we're talking about today is a scenario where we have a relationship where the dependent variable changes by some constant value only. Okay? All right? So let's take a look at a couple of examples. The power P of a gear varies directly with the radius R of a gear. Find the constant of proportionality if P equals 300 when R equals 50. So what we're saying is P, the power, is a function of some constant times the radius. Okay? So now what I just simply do is 300 equals K times 50. So that constant is 6. And all that means is that if I change the radius, all right, of the gear to some number other than 50, it changes the power that is generated by this factor of 6. All right? Example 2. Inventory. Profit directly varies with inventory. So find find P when I is 50. All right? Now you'll see why it's a constant of proportionality is the other term used. So what we're saying is P is equal to some constant times the inventory. So one way to solve this problem is that 100 equals some number times 20, so that we can easily see that K is 5, right? Now, when I'm trying to find P when I is 50, well, K is 5, so that stays. 50 is my new inventory amount. So when the inventory is at 50, the profit becomes 250. Now, what could you have also done? You could have set up a proportion. 100 is to 20 as some number is to 50. All right? And you could have figured that out. And the reason is that in proportions, they are equivalent fractions or equivalent ratios because they are multiplied by the same constant. So that's why that other term is used. All right? Let's look at number 3. If p varies directly as q, and p equals 7 when q equals 9, find p when q equals 12. So, p varies directly with q. I can do that, which is 7 over 9 is equal to p over 12. How do you solve these? You cross multiply. 9p equals 84. So p is 9 and 1/3, or 9, 3 repeating. Okay? Now, which table does not show an example of a direct variation? So what this means is, what you have to figure out, if there is a one value for x, a constant value for x, that when you multiply it, you get this value of y. So if you look here, x is being multiplied by 4, so that's a direct variation. If you look here, every x value is being multiplied by a half, so that's a direct variation. If you look here, I'm multiplying this by 12, this by 3, this by 1 and 2/3, or some value like that. This is a number even less than 1, so this is not a direct variation. And here I'm multiplying everything by 5, so that is a direct variation. It's as straightforward as that. Okay? And then the last thing, determine if each equation is a direct variation or not, and if so, determine the constant of variation. Well, this should be pretty straightforward, because you can see here I have no y-intercept attached, so this is a direct variation. And what is the constant of proportionality? Well, I divide by 7, so that I get the equation y equals 2 over 7x. And so my constant of proportionality is just 2/7. Here, you should see that when I get this to be y equals, this is not a direct variation, because it's not in the form y equals kx. In other words, I have a value attached by addition or subtraction to my first part, my constant part, or in other words, I have a y-intercept other than 0. So, today's lesson, just very straightforward, is just introducing to you a specific type of linear function, which is called a direct variation.